Hello YouTube and welcome to What the Math. Today I'm taking a look at another educational video game. This time it's a game called Species Artificial Life Real Evolution. Now it says it's still in alpha, meaning that it's not actually officially out yet, but you can buy it and support the developers by playing the alpha and beta versions. It's a game that's really worth trying, especially if you're a biology teacher, because this can be an excellent biology virtual lab. Let me show you what it's like. You start by creating a world, and I'm going to create a world that has, it's a randomly generated world, so you can change different settings, but I'm going to create a world that has several islands, several continents, because I want to simulate this as closely to reality as possible. So this was pretty good. Let's generate it, and basically initial number of creatures is going to be 250, and this is going to be our first initial creature. Or should I just randomize it? Now I'm going to start with a blank slate. You can actually randomize creatures and start with various pre-generated creatures, but we're just going to start with something that is absolutely genetically identical. And welcome to the new world. So this is what it looks like. These are the beautiful, cute little creatures there. I believe the name for them is Primum or Primum Specium, first species. So yeah, there you go. So this is a start. Now what can you do in this game? Well, as a biological experiment or as a biological lab, you can do quite a lot. As you progress through generations of these species, as they basically procreate, you'll see that they start changing, they start mutating, they start acquiring different characteristics, but you can actually influence that. You can actually, first of all, here you can actually mutate them. You can use a radiation gun to mutate them. Usually with more advanced creatures you can see it right away, but with these creatures it's probably going to be hard to see. But these guys are now mutants. This is a mutant, and let's make a few more mutants to introduce various genetic components. Mutant. Alright, so we have 5 mutants now. You can also gene splice. You can actually add features from one creature into the other creature. Now, it won't change the species, it won't change the creatures themselves, but it will affect their progeny. It will affect their kids. So I'm gonna... Oh, there's some love going on here. I'm gonna take this guy and splice him with this guy. And I'm gonna take this guy and splice him with this guy. And there you go, love time. And they will mix and shuffle their own genetic material and create a new species, with a combination of their genes. Now, because this is still kind of sort of more or less similar in terms of genetics, it will take a while for them to develop into a variety of species. So I'm going to accelerate time and wait for them to basically create at least 1,000 different creatures, which is actually a number right here. I'm going to wait for this to get to 1,000. Now, the other thing you can do in this game is introduce something called rovers, and basically these are like bots that you can... Oh, where are they? They're right here. Oh no, the game is slowed down dramatically because I'm getting so many species, and also because I'm running this at really high speed. Alright, rovers are right here, and these are basically robots that will do as you tell them to do. So for example, you can add a rover that will feed every creature with high, let's just say, head size. So everyone that has... Oh, no, not head type, head size. Everyone that has a really bad head will get fed and will survive, whereas the other creatures with smaller heads will not get the food, so they're very unlikely to survive. You can also add a rover that will kill creatures. So I can, for example, kill everything that has small head. How about small head? No, let's do something else. Let's do, let's just say low eating rate. So the creatures that eat low or don't eat enough will be killed. So basically, our rovers will try to encourage big head growth and discourage creatures that don't eat enough. We're gonna run this for a few generations and then see what we develop here, because biologically speaking, genetically speaking, I should now have a lot more big-headed creatures and a lot less creatures that don't eat anymore. Now, one of the coolest features in this game is that, actually I'm going to show you while I'm waiting for the creatures to develop. You can actually look at individual creature and see everything about them. You can see various features, various psychology features and attributes that they have. You can also even look at their energy, current energy, and how much energy they consume. They can look at their physiology, so head size, neck size, tail size, and even genetics. So this is like grade 12 right here. And basically you can look at their genetic code and then see how it differs from other genetic codes of other creatures. And if you really want to have an advanced class, you can even go as far as trying to decode genetic code on various creatures based on, for example, tail size, because you can actually export each individual creature There's an export creature button right here, and you can then look at it individually in the game menu. Now, you may also notice that the environment also changes a lot. So as these guys are eating the grass from this mountain, it's actually turning into desert, which is quite realistic because they are basically overpopulating the planet. And because they're overpopulating the planet, they are destroying the environment. So this is actually another really good topic to look at, you know, the environmental effects of overpopulation and so on and so forth. Now, with time, you can see that the landscape actually recovers, which is also a very realistic effect because, you know, Earth knows how to recover itself as long as you don't touch it. And so this area is recovering because there's no creatures here eating the grass. And so eventually, they might be able to resettle here again. So this is a pretty awesome topic to cover. But we're more concerned with biology, specifically with genetics and genetic components. Or not components, sorry, what am I talking about? We're more concerned with the reproduction and various traits of different animals. So here we go. Here's some limbic creatures here that are being reproduced, and these guys have big heads. Look at that. This is a big head community, big head society that is basically the result of my drone or my rover feeding all of the big heads. Okay, so it seems like on this continent everyone died. These are the last two bodies that were unfortunately left after the unsuccessful procreation on that island, but this continent is doing good. There's some funny looking two-legged long creatures that managed to develop on this particular continent, and they seem to be doing okay, but not as good as some of these other creatures on the mainland. So look at that, look at that thing. This is a huge looking thing. And this is all a result of, oh no, it just died. It's all a result of randomly, oh, what's happening? Oh yeah, and so these funny looking creatures are all a result of random procreation, random natural selection, and so on and so forth. So this is an excellent way of introducing this idea. Right here it says I currently have 8 species. I can actually take a look at them. Oh, now it's 7. Okay, so one of the species died. And this button right here, I can actually select different species. So there's this guy, there's 24 of them. Then there's this guy, there's 16 of them. Oh my god, this creature is awesome. I may actually export this because this is craziest looking creature ever. And there's 70 of them. And there's 14 two-legged, one-eyed monster thingies, and there's 2 of these. And so on and so forth. So as we progress, oh my god, this is cool too. As we progress, we'll actually get more species, or possibly less species as they become extinct. And this is a pretty awesome simulation of, you know, how natural selection works. I'm actually going to advance this game through a few more generations. High stamina, I think, and let's see how this goes. And also, we're going to feed creatures that have high or actually low diet, so they don't actually eat as much as other creatures. And then we're going to wait a little bit more and see what happens. And after a few more generations, this is what I have so far. I have an omnivore that looks like this. I have an omnivore that looks like this. I actually developed a carnivore by introducing another option of creatures that do not like trees. And this is my first carnivore, Primum spam. I guess that's what it's called. There's an omnivore right here. There's another carnivore that's similar to the other one, and so on and so forth. So now, if we just remove the what do you call them, the robots, the rovers, and we just let this run indefinitely, we will have a population that will stabilize, and it won't really go more than 300 animals at the same time, because carnivores will be taking care of omnivores, omnivores will be eating grass, and the grass will eventually be, in certain areas it will regrow, in certain areas it will be destroyed, and then this will be kind of a very balanced ecosystem that you can actually create. Now, the cool thing about this game is that you can also, on top of the genetics and on top of the speciation and all that, you can actually change the environment, which is actually one of the coolest features here. So if I go into the ecosystem mode, I can change everything from temperature, so I can make it really cold or really warm, to fertility rate of creatures, making them reproduce even faster, to water level. I can actually raise or lower the water level. So what I'm going to do is simulate the global warming, of course. We're gonna start raising temperature by a little bit every minute or so and see what happens. So currently we have almost 300, so 250 species. that are kind of like running around everywhere. They're sort of destroying the world, but not really. They're actually living quite peacefully. But let's just say there's a sudden global warming. So I'm going to increase water level by 1 point, and then I'm going to increase temperature by 1 point as well. And let's see what happens. So as my water level increases, a lot of creatures find themselves in the water, and I think a lot of them cannot swim actually, meaning that they will probably not survive this for very long. I'm going to fluctuate this a little bit, going up and down, just to give them a chance to survive. I'm going to now lower it by 2 points, and then this will actually simulate the fluctuation in water levels as well, and also fluctuate the temperature a little bit. So now it's going to be really cold this year. So let's see what happens now. And as the water level starts to fluctuate, opening up some of the passages and closing up the other passages, my creatures start to migrate. So this is kind of an example of what might have happened during the Ice Age, where water level was pretty low, so creatures were able to migrate from one continent to the other. But now let's go back up. Let's actually start increasing temperature again and raising the water level. So maybe some of them migrated here, maybe not. I think actually nobody did. Some of them tried, but they died on the way. Let's see how they're doing on the other continent. Oh yeah, the other continent has a lot more population, because some of the legged creatures were able to run across and settle here. But now a lot of them find themselves in the water, so let's see what happens. I'm gonna accelerate this again and increase my temperature and water level by 1 more unit. And you can see the numbers of creatures left here, so they're already starting to die out. I'm gonna remove the rest of the rovers too, actually, just so that nobody feeds them. They have to survive on their own. And suddenly, even though I increased my water level by just 1 unit and my temperature by just 1 unit, we already have 1/5 of the creatures that died. Actually, even more than that. So there's 11 species left, but only 70 creatures. So I'm gonna keep this running without increasing any temperature or water level and see what happens. And chances are there might be almost nobody left. And really, the only creatures that are left are on this tiny continent. They're kind of surviving here. I don't know how they're doing it, but they're doing it somehow. Because I think every other continent is absolutely extinct. There's not a single creature left, even though I increased my water by just a little bit. And my temperature went up just a little bit. No, there's actually one more continent that has a little bit of animals, but there's only 7 of them left. And this is literally almost complete mass extinction after just 1 increase of water and temperature. So there you have it. This is a pretty scary stuff. And because I increased the temperature, now we have a new type of a plant that started growing. This is actually like sort of like a palm tree that started to appear in certain areas of the continent. But I don't know if these guys will actually benefit from it, because they are pretty close to extinction. There's only 6 of them left, and they have to try pretty hard to survive now. And these, of course, are omnivores. They'll eat everything. They're not carnivores. All the carnivores are dead. There's only omnivores left. But as you can see, because there's almost nobody left in the world, there's only 7 of them. All of my ecosystem started to recover. So this mountain is getting greener again. These areas are completely recovered. This is also recovered. There's trees everywhere. And except for this one. This one is still kind of dead-ish. But everywhere else in the world, there's a almost complete recovery, including this mountain. So I think once this mountain recovers and lets these creatures pass to this area, they'll be able to repopulate the world, because there's already 20 of them again. So the cool thing about this simulation is that it shows you the effects of global warming and basically catastrophic atmospheric changes. So if there is some kind of a sudden change in the environment, yes, there will be huge extinction, but the creatures that can adapt to this kind of a condition will survive. So you can see these guys start thriving again, because now there's 40 of them, and I'm just gonna let this run for a few more generations just to see if they do survive this, if they can actually recover, or if they die forever. Now, after a few generations, this is what happened to this island that was previously completely dead. There's vegetation all over it. This island is covered in vegetation too, and most of this area is basically a jungle. So this is actually very, very good conditions for life. But unfortunately, oh, here we go. First dude that found his way back to the prosperous area. So now these creatures will prosper again, and they will try to eat everything and most likely destroy everything again, because as you can see, this island is almost bare. And this is a kind of a cycle that you'll see a lot and can simulate a lot in this game, which is actually pretty awesome. But the species will continuously change, continuously evolve. They'll continuously expand their necks, for example, to reach taller trees, or they'll start walking on twos just to move faster or more efficiently. Or they'll start developing powerful teeth because they might be carnivores. So in that way, the game simulates this very, very well. So you can see that now they're back to 200s and going up. So just to kind of show you the effects of mass extinction, or sorry, change of environment and change of temperature, I'm going to increase this by one more. So 1 more degree, or 0.4 degrees, and 0.3 or 30 centimeters of water level. So let's see what happens and how these creatures fare with this new atmospheric change. Because a sudden increase in numbers of these creatures will probably have quite a significant atmospheric effect. And these guys are going crazy. There's like almost 400 of them all over the continent that was basically all luscious and beautiful, and they're eating everything. Look at that, they're eating absolutely everything. Even though the temperature and the water level increase, they're trying to destroy the rest of the resources because they're hungry and there's a lot of it. And this is essentially what kind of humans are doing at this moment. We're sort of using up the resources without replenishing them. And this is a very good simulation of what's going to happen next. Now the numbers started falling already. They're back to 80s, 70s, 60s, 50s. And falling even faster. There's very, very little of them left now. This is only within one generation. This is not even 2 generations. This is after 1 generation. There's only 23 animals left. Let's see who they are. And they're all very different, actually. Look at that. They all have different features, even different colors. But they don't have very long to live. So these cacti-looking long cucumbers don't really have anything left to eat. There's no trees here. There's just actually just one tree right here, and I don't think that will actually make them last. And this was technically my second mass extinction. Now we can actually check and see if they survive this mass extinction, and chances are they will, because this will once again recover. These guys will probably survive because there's some food left, and they will then start taking over the land yet again. So this is a very good simulation for 5 or so mass extinction that we had on our planet, and can actually show the students how mass extinction happens and then how the animal life recovers after it. So we're back into 40s and 50s now, so these guys are actually striving again, and we have a completely different species that developed. We have a 4-legged giraffe-looking thing and a cactus, walking cactus with upside-down tail. So what I'm going to do now is I'm actually going to simulate a real mass extinction, where in a case where you increase your temperature and your water level too fast. So this is what our race is doing currently with all of this sudden introduction of CO2 and various other gases that cause basically the warming effect. So the greenhouse gases are going to accumulate every half generation. And as they accumulate, they increase the temperature and also the water level. So my water level will start going up and my temperature starts going up again. And these guys have to swim now. A lot of them have to start swimming. There's almost no food left, very few islands in the world. And this is only plus, I think, 1 meter of water from the previous generation. Or not even this, I think it's only half a meter of water. And now there's only 15 left, 13, 11. And suddenly they are actually in trouble, because not only is there no food, there's nowhere to eat that food, because the islands that do remain are completely barren. There's almost nothing left. There's one creature left, and this creature is about to die as well. It's actually right here. This is the last survivor, and mass extinction just occurred. So this is only after about 50 centimeter increase in water level, and an awesome example of how mass extinction can occur if you basically have uncontrollable consumption of things. Alright, so this game is absolutely amazing to simulate all of these amazing biology topics. I definitely recommend this to biology teachers, to teachers that want to explore various topics in class, and that want to have a kind of an inquiry-based biology learning using computer labs and video games. This game is called Species, Artificial Life, Real Evolution. Now this is actually an older version. There's a 0.7 alpha version that's out right now. And I'm posting the link for this game in the descriptions below. So do check it out. It's only about $9 per copy. And you don't really need to buy copies forever. And you can even just use one copy. And thank you for watching. Please subscribe, check out some of the other videos, and good luck to you. Bye-bye.